Welcome to Introductory Chemistry with Dr. H. This is a video about solutions and electrolytes. What I'm going to talk about is the process of forming solutions, and then we're going to talk about the different types of electrolytes that we can have in solution. So what does it mean for something to go into solution? We're going to start with something familiar, sodium chloride, a salt that you're familiar with. This is a table salt. And as we already know, sodium chloride is an ionic compound, so it exists as a solid in this infinite lattice of positive and negative ions, where the positive ions are the sodiums and the negative ions are the chlorides. And what happens when you drop that lattice into water is that those ions are surrounded by water. And so a few terms to keep this straight. When we're making a solution of sodium chloride, the solute is the thing you're dissolving, so sodium chloride solid. The solvent is the molecule that's in greater abundance. There's always a lot more water than there is salt when you're making a salt solution. So the solvent is the water in this case. And the process that's happening is the lattice is breaking down and the sodium ions are coming away from the chloride ions. And what's really happening at the molecular level is they're being surrounded by water. So if you want to take a look at this picture, this would be just a tiny, tiny fleck of salt. Here, sodium and chloride ions in their lattice. And what happens is they're surrounded by water molecules. And it's important to remember that water is a polar molecule, so the oxygen is more electronegative than the hydrogen, so there's a tiny negative charge that exists on the oxygen side of water. Those tiny negative charges like to interact with the positive charges on cations, so they tend to point in the direction of those cations. That's also something that stabilizes the cations. And so this is the reason why the sodium ions like to depart from the solid, because they interact strongly with water. Similarly, the anion part, the chlorides, interact with the positively charged hydrogen atoms that are a part of the water molecule. And so these interactions between the positive hydrogens and the negative chloride ions are what stabilize the chloride ions. And so salt, as you know, when you put it into water, the solid disappears completely and you have a solution. So you couldn't even tell the salt was there. But what's happening is the sodium and chloride ions are just being surrounded by water. We call that the process of solvation, or the total process is dissolution. When a salt totally dissolves, it's dissolution. So that's what the process of solution is. Let's talk about this term called electrolytes. When you have ions in solution, much like electrons in a wire, they can carry electrical current, and that's where you see the word electro, right? Because this has to do with the carrying electric current. When you take water doesn't have lots of ions in it on its own, and so it has trouble carrying electric current. And so it's a very weak electrolyte. However, if you take a salt like sodium chloride and dissolve it in water, it will dissolve completely. So here's the process of dissolution that we were just talking about. You drop a chunk of salt into water, and over time the salt dissolves, and so the cations, the sodium cations and the chloride anions are going to start to be surrounded by water. And as you know, if you stir it up or you wait long enough, all of that solid will dissolve. And the result is you're going to have tons of ions in that water solution. Those ions can carry charge just like an electron in a wire. And so something like sodium chloride that dissolves readily in water and produces lots of ions is a strong electrolyte, meaning it makes water conduct electricity well. So when we're talking about strong electrolytes, things like soluble ionic compounds like sodium chloride. And just a hint, not all ionic compounds are highly soluble. And in our next video, we're going to talk about how to predict whether a compound will dissolve readily in water. For now, we know sodium chloride does, so we're just going to call that one an example of a strong electrolyte. Strong acids, things you're already familiar with, like hydrochloric acid, nitric acid, perchloric acid, and sulfuric acid. Those are strong acids. And so what that means is they're molecular when you drop them into water. So here's hydrochloric acid. We've called it aqueous because it's like a molecule of hydrochloric acid in water. And what happens readily, because it's a strong acid, is the hydrogen and the chloride dissociate from one another, and they make hydrogen cations, protons, and they make chloride ions. So because now there are lots of ions in solution, even though we started with a molecular compound, we dropped it into water and it becomes ions. Those ions can carry electricity. So we call that also a strong electrolyte. So these are all examples of strong electrolytes. Strong acids are also strong electrolytes. Similarly, the strong bases, things like sodium and potassium hydroxide, they completely dissociate in water. That's what makes them strong. So sodium hydroxide dissociates into sodium ions, right, cations, and hydroxide anions. That's what makes this a base, because hydroxide is a strong base. So we have cations and anions in solution again, and those cations and anions then can carry electrical current. So these are examples of strong electrolytes. Well, let's look at some of the weaker electrolytes. So weak electrolytes also produce ions in solution, but they only produce a few ions, not very many. So they have solutions of weak electrolytes can carry electrical current, but only a little bit. So examples of that, hydrofluoric acid. So we know that hydrochloric acid and hydrobromic acid are strong acids. Hydrofluoric acid is not a strong acid. It dissociates into protons and fluoride ions, but only slightly. So there aren't very many cations and anions in solution. So the way I've kind of illustrated it here in this picture is here are the HF molecules floating around. And after you wait a while, there's a few cations and anions, but most of the HF is still a molecule. So that molecule doesn't have a positive or a negative charge. So it, as a molecule, can't carry charge. Only when it breaks apart into cations and anions can it carry a charge. So we would call this a weak electrolyte. So weak acids are examples of weak electrolytes. Slightly soluble ionic compounds, those that don't dissolve much but dissolve a little, are also weak electrolytes. I haven't included it on the slide, but you can kind of imagine that. If salt only dissolved a little bit, table salt dissolves a lot, but there are salts that only dissolve a little bit, they would be weak electrolytes. Another example is the weak bases. So we're familiar with ammonia. Ammonia is a weak base. So ammonia will take a proton from water, just a little bit, to form a little bit of hydroxide and a little bit of ammonium ion. So because this reaction really favors these molecular compounds without a charge, it really only forms a little bit of these ions, there are only a few ions in solution to carry charge. So those we call weak electrolytes. We're going to be looking at examples all along, and we're also going to be building your skills to figure out whether something is strong or weak based on the properties of the acid or the base or the salt as we go. This is just kind of an introduction to weak and strong electrolytes. There are also compounds that are not electrolytes at all, meaning they're molecular compounds and you put them into water and they don't generate charges. They don't dissolve at all into charges. So the example that your book likes to use are things like alcohols, methanol, and ethanol. So these are molecules that are similar to water and they don't have the property of dissolving into ions. And so in this picture down here, methanol and water interact through those slight positive and negative charges, but the methanol doesn't break apart. So you could watch this solution as long as you want, and you're still going to have methanol as a molecule with no charges surrounded by water. There's no process going on here. These are just it's just a solution of methanol in water or a solution of ethanol in water, and there are no additional charges. Compounds that have that property remain molecular. They don't break up into ions, and we call those non-electrolytes. So that's my introduction to the process of dissolution, or how solutions are formed, and electrolytes. I hope you found this video useful.